So, everybody ready? So let's talk about the two-word problems. The first word problem is about is number 17 on the first page of your worksheet, and it's about swimming pools. I really, really, really felt like you should have been able to get this problem, okay? And some of the crazy stuff that y'all did makes me doubt my teaching abilities. But anyway, swimming pools. You're considering buying a swimming pool and have narrowed the choices between one that is circular and one that is rectangular. The depth of the rectangular pool is 1/3 the width. Okay, so let's just draw a picture. All right. Now, yes, it is rectangular, but it's not just rectangular. It's a three-dimensional figure, guys. Okay. So I'm going to draw a three-dimensional figure because then it actually gets the concept in my head a little bit better. Okay, so there's my rectangular swimming pool. Now, here's what it says. The depth of the pool is 1/3 the width. So what are we going to call the width? X or something? I'm going to call it X. All right, so what's the depth going to be? 1/3 X. Now look, I'm just going to tell you, you can write 1/3 X. There's nothing wrong with it. There will be sometimes I'll use 1/3 X. But a lot of the times, it's easier if I write it as what? Yeah, X/3. And this is one of those times that, because I could be multiplying it by other things, other fractions, squaring it, and do things like that. It's easier if it's looked at like this, okay? Nothing wrong with doing it like this. I'm okay with that, all right? It says the length of the swimming pool is twice the width. So what's this side going to be? 2X. And then you have a circular pool. All right, now here's what they said about the circular pool. The circular pool has the same depth as the rectangular pool. So it's still 1/3 X, or I'm going to call it X/3. It says the diameter of the circular pool is the same as the width of this one. So like they're the same width is what they're kind of saying. But in the formulas and stuff, I very seldom use diameter. Almost always I use radius. So if the diameter is X, what's the radius? Yeah, X/2. Okay, so here's what they tell me to do. Find the ratio. What's a ratio? It's just a fraction. A proportion is two fractions set equal to each other. That's what a proportion is. A ratio is simply a fraction. And here's what they say. Find the ratio of the volume of the circular pool to the volume of the rectangular pool. That's all they wanted, guys. Find the volume of the circular pool, put it on top. Volume of the rectangular pool, put it on the bottom. Okay? So let's find the volume of the circular pool. So here's my circular pool. Volume of a cylinder, that's what that is, guys, like a can of tuna or something, okay? So volume is area of the base. What's the area of a circle? Pi r squared times the height. That's the volume. So pi times, what is the radius? X/2. Quantity squared times, what's the height? X/3. Now, just this one little bit of the problem shows you how much easier. Look, I'm going to erase this, but I'm going to show you what it would. Some of y'all wrote it like this, and how much more difficult it appears to be like this. Because some of y'all did squared this, but you forgot to square the 1/2. Okay? I mean, see right here, would I ever forget to square the 2? No, because you look at that and you go, oh, got to square the top and square the bottom. Okay? So it is easier sometimes when you write it that way. So just know that that works. So that's going to be, let's see, we got to square it first, right? So pi times square X/2, and what do you get? X²/4 times X/3. Now, I've got to multiply all these things together. What do I do with that pi? Where is he? On the top or the bottom? Yeah, y'all, he's over a 1. Okay? You can't put him under a 1. So now when I multiply all the tops, I just get pi times x to the third over what? 12. That's this volume right here. Pi times x to the third over 12. Over. Now let's find the volume of this. Now guys, should we have been able to do that? Yeah. Y'all, you should have been able to do that. Okay. Now let's do the volume of the rectangle. Volume of a rectangle, a rectangular prism, actually what it's called, is just, I say length times width times height. So my length is 2x, my width is x, and my height is x over 3. So if I want them all to look alike, what do I do with these two? Put them over 1. How do you multiply fractions? Multiply all the top, multiply all the bottom. Okay? So what's 2x times x times x? What's 1 times 1 times 3? 3. So that goes on the bottom. Now, this part amazed me. I had some kids that got this right here, and they wrote that in the blank. I'm like, you've got to be kidding me. That's a complex fraction. I taught you how to get rid of complex fractions. Okay? You can't put a fraction within a fraction for an answer. Okay? Because I'm going to mark it wrong every time. So, how do you divide, because that's what this line means, how do you divide fractions? Flip the second and multiply. So this becomes times 3 goes on the top, 2x to the third goes on the bottom. Okay? Now we got some more people, and they got this far. And then they wrote 3 pi x to the third over 24 x to the third. And I'm like, what? Y'all, come on, it's called a transfer of knowledge, people. All the stuff I'm teaching you, guess what I want you to do?
Apply.
Use it. Yeah, apply it. So cross cancel. What happens to my x to the third? They cancel out. All right, anything else?
3 and 12.
3 and 12. 3 goes into 3 and 1. 3 goes into 12, 4. So what's the only thing left on the top? On the bottom was 4 times 2. Look at that. You're telling me all that stinking mess. And look at that beautiful answer. A lot of people got 1 over 8 pi.
I did 2 times 3.
Oh, that's terrible. Why are you multiplying 2 times 3?
Over there, I don't know. I was like, I have to do the bottom. And
No, you have to square it. Oh, okay. All right, so everybody okay? Now let's turn to the back of the page, and let's work this next one. Okay, now this is a physics problem. If you are not a sophomore, but you are a junior or a senior, then you've probably seen some problems like this. Because in physics, that's what you talk about resistors, you talk about ohms, and all that kind of mess. Now listen to me. This has to do with electricity, in case you didn't know, okay? So, am I an electrician? No. People, I don't even like to plug stuff in, okay? I know I'm going to get shocked. I don't like it. If I don't have to plug something in, I can find somebody to do it for me, I'll say, hey, plug that in for me. I don't like it. I've stuck a bobby pin in the plug-in when I was little because my sister said it won't do anything, Billy Gates. Just stick it in there. And I did. Yes, she lied. So it did do something. This it hurt. Terrible. Stuck a bobby pin in a socket. It shocks the mess out of you.
I told my brother that sticking an air pump in his mouth would give him extra oxygen. That makes him smarter. I was like 6 and he was like 3.
Oh, yeah. Okay, so here's what we got. We have a parallel circuit and it has 3 resistors on it. Resistor 1, resistor 2, and resistor 3. This is the formula, okay, for the resistance that they give. And then, oh my word, these people in this worksheet were so nice. They even simplified this complex fraction for you. Okay? Now, should you have been able to do that? Yeah. People, what do? You make one fraction on the top. Oh, got that. And then one fraction on the bottom. That means you have to add these 3 things, which means you find a common denominator between R1, R2, and R3, what is it? R1, R2, and R3. Okay? And then what do you multiply this one by to make it look like this one? R2 and R3. What do you multiply this one by? R1 and R3. What do you multiply this one by? R1 and R2. And then all of that's under 1, so then you flip it and multiply, and guess what you get, people? R1, R2, R3, see, this comes on the top, over R1, R2, plus R2, R3, plus R1, R3. Okay, so then they told you, hey guys, this is equal to this. This is that mess simplified. Okay? So then they said, hey, what if we had 4 resistors? Okay? What if you had 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4? Now, I could have been that stubborn little kid that said, hey, I'm going to find a common denominator, and I'm going to get it, and I'm going to turn this into one fraction, and then I'm going to flip it and multiply it. You could have done that. But remember what I said about the kids that are really good in math and really fast? What do they see? Patterns. Look at the pattern, people. All the resistors multiplied on top. So what goes on the top? Okay. Yeah. All right. So here's the pattern that a lot of kids miss. Okay. How many resistors do I have in this top equation? 3. How many terms do I have in the denominator? 3. 1, 2, 3 terms. 3 resistors, 3 terms. Wonder how many terms I'm going to have down here? 4 terms. All right, so I already know I'm going to have 4 terms. Notice something else. 3 resistors, and each term involves how many of those? 2 of them. So with 4 resistors, each of those 4 terms is going to involve how many? 3 of them. And all I'm going to do is just make different combinations of 3. Guess how many combinations of these 4 I can make of 3? Guess how many of them? 4. That's all you can do, people. Okay? So I'll start it off. I'm going to make the first one. R1, R2, R3. Plus, tell me another one. R1, R2, R4. Plus, tell me another one. Now, obviously, we have another one, people. R1, R3, and R4. That's it, guys. That's your answer. Now, that's not bad. Is that bad? I didn't even have to do any work. I just had to do some thinking. Okay? Now, the answer to number 18, people, I would have used this formula right here. Okay? I would have used this formula right here. Why? Because, people, if I mess this up, guess what I'm going to mess up too? Number 18, right? You're going to mess that one up. So I just take this one, and I'd say 1, I do a fraction button, 1 over, and then I do another fraction button, 1 over 6 plus 1 over 12 plus 1 over 18 plus 1 over 24. Press the enter button, and it'll tell you 72 over 25. Okay? 72 over 25. A lot of people got the 72 over 25 and still messed up all the other stuff, so they did the right thing, too. I would do that. All right, anybody got a question? No? Everybody okay? All right, so now I want you to turn in your notes to the problem that we did. I think I called it example 5. I hope I did, because that's really what it is in your book. One class I've already found, I called it example 6. It's the one that looks like this. 6, no, that's example 2. 6 over x minus 3 equals 8. It's the one right before that. 8x squared over x squared minus 9 minus 4x over x plus 3. Do y'all remember that one? Okay? If you were here, you remember it. We worked it all down, right? And we got 2 answers. What were they? 3 halves and -3. And then what did we find out when we checked it? -3 was extraneous. So actually the only root is 3/2. Is everybody okay? Except for the people that weren't here. All right? That was yesterday. Okay? And I just got the video because Luke helped me figure out what the problem was. It was Tanner. Okay? And so we nixed him out, right? Took him out of the equation, and it went back to my account, okay? And then I loaded the video like I normally do after this class. All right, so now it's on there. If you weren't here yesterday, you can go and look on YouTube and see the video. All right, so what would it be called? It was called 8.6b, Solving Rational Equations. There was an 8.6a, and it was called Solving Rational Equations also, but we just barely got into it that day. We only did like 2 problems, okay? So we finished it up the next day, all right? And it would have been the last video that was added. I think, aren't they in order when you pull them up? They're usually in order, so you can usually tell. Does it tell the date that I loaded them?
A year ago, a day ago.
Oh, if you go to playlist, it doesn't. Okay.
If you click on it, it says published on.
Published on. And normally, not this one, because I got messed up, okay, but normally they're published on the day that I teach them. Because normally right after this class is over, I go over there and I upload my video to this class. Okay? All right. So, yeah, it'll say published today, the 30th. All right. So what I want to do is I want to show you another way to check your answers. I showed you one way where you took them and you plugged those numbers back in and make sure everything was good, right? I want to show you another way, okay? If I take my calculator, all right, so get your calculator, and I put this in Y1, and I put this in Y2, you do that, okay? You do that. Now, you have the problem. I'm fixing to get off of here because I have to re-enter it into the calculator. All right, so you might have to look on your notes. Because I promise you, you're not going to want to enter it the way I'm entering it. Because, I'm going to cheat, okay? See, I'm going to do this. Y'all put it in Y1 and Y2, okay? Because it's so much trouble. Can you see how much trouble it is for me to have to enter those equations? Okay, see, I don't have a fraction button, so I have to use like 9 bazillion parentheses, okay? So I'm going to put mine in 3 and 4. I've turned those 2 equations off. So, where are they? 6 over x minus 3.
Wait, how do you turn this?
You go to the equal sign and you, what? Hello? You go to the equal sign and you unhighlight it. Come on, you big goose.
Oh, I see.
How come it's not turning it on?
No idea.
I don't know. Mine's not seeming to do it either, but it's supposed to. 6 divided by x. Oh, now it is. I just didn't have anything in there, so it was like going, what are you talking about, lady? 6x minus, you don't have anything to turn on. All right, so there's the left side. The right side can be a little bit more difficult. Used to, we had to teach kids how to do this. That just involved more math.
I'm pretty sure that's how I did it.
Yeah, I'm sure it is.
To plug it in like that. Yeah. They're taking that practice again. That's how you have to plug it into the
Oh, is it really?
that part. But it like shows you a preview so you know what it looks like.
Yeah. Okay, so now, here's what I'm going to do. I'm going to graph them. Now, what were our two possible answers? 3/2 and -3. Okay? Now, what am I looking for where they do what? Where they meet, where they intersect. Okay? So, look here at -3. When x is -3, do they intersect, people? Of course they don't, because that's not a solution. You understand? I do see them crossing over here somewhere, so I'm going to find that and check my stuff. I'm going to go second and calculate. What do I want to calculate? Number 5, an intersection. Look what my little spider's doing. He's jumping up and down on this one, and he's saying, hey, lady, is that your first curve? There's the equation that I put in there. Okay? So I say yes by pressing enter. Now look at him. Now he jumps to the second one, and he said, hey, is that your second curve? Yeah, that's the crazy one I put in. So, no, I don't want to guess, Mr. Calculator. So I just press enter, and he tells me. Now listen, what am I looking at, the x or the y? People, your problem didn't even have a y in it, did it? Okay? So you can't be talking about the y's. We were just using a graph to help us find the answer. So there's your answer, 1.5, which is 3/2, which is what we got. Okay?
Question. What are the other lines?
They're all part of the graph. This line right here and this line is the graph of the 6 over x minus 3, and this one is the graph of the other one. Pretty cool, huh?
Yeah.
We're going to graph these. They're called rational functions, and we're going to graph them, but it's going to be towards the end of school, okay? It'll be towards the end of school. They're not really hard to graph, but they have some kind of weird things that happen to them. But they're pretty cool. I'll teach you everything you need to know about them, so it won't be bad.
Wait, what are the other lines?
They're part of the graph. See, when you graph a rational function, this is what it looks like. This is the parent function of a rational function. Okay? And what it has what's called asymptotes. All right? Sounds like you said a bad word, but you don't. All right? And asymptotes are just numbers actually they're lines that your graph approaches. See, this graph right here, this curve right here gets closer and closer and closer and closer and closer to the x-axis, but he never ever gets there. Pretty cool, huh?
Why not?
He does the same here. Because he can't be 0.
But how can you
Because watch, if I have 1 over x, that's what this is the graph of. If I have 1 over x, right? The bigger I make the x, the smaller that fraction gets, right? That's the closer he gets to 0. Can he ever be 0? No, you got a 1 on top, people. The only way to make a fraction 0 is put a 0 on top. And you can't change that 1. It's 1 over x. The only thing you can change is the bottom. Okay? So, we'll talk about it. It's okay. It's nothing we have to worry about right now. All right. So, let me ask you another question. What about this? What if I had 7x over x squared minus 4 plus, okay, plus 3 over x plus 2. All right, what's the first thing you guys are going to do? Yeah, you're going to factor. I'd say most of you are going to look at that and go, whoa, I need to factor that thing. I'm not really, some of y'all will be saying, I'm not really sure why, but I remember her saying that, okay? So what does x squared minus 4 factor into?
X plus 2x minus 2.
All right, so now this is my denominator. Now, why did I do that?
Because now you have that, you can find your least common denominator.
That's exactly right. Now I can find my least common denominator. And what is my least common denominator?
X plus 2x.
Very good. Now, here's my question. Am I going to multiply both of these by x plus 2, x minus 2, so I can make the denominators go away?
No.
Why not?
It's not a proportion.
That's right. It doesn't have a what? An equal sign. Okay? Now, y'all listen to me, because you listen to what just happened. Okay? I just asked you that, and half of the class said, yeah, we're going to multiply everything by x plus 2, x minus 2, and make the bottom part go away. People, the only time you can do that is when you see an equal sign. There is no equal sign in this problem. All you're doing is finding a common denominator. It's an expression. That's exactly right. It's not an equation. All you're doing is finding a common denominator. Now, you already told me what the common denominator was, right? What did you say the common denominator was? Okay, so remember, now this is like the first kind of problems that we learned how to write. All right, so you write the denominator at the bottom, x plus 2, x minus 2. And then you say, what do I need to do to this denominator to make him look like this? Nothing. So you don't do nothing to him. You just write him down. What do I need to do to this denominator to make him look like this? So I'm going to multiply the top by x minus 2. And I put my visuals there so I don't make a careless mistake. Okay? What do you get?
3x minus 2.
Very good. And then, what's 7x and 3x? 10x minus 6. Now, y'all listen to me. On problems on the worksheet that I just gave back to you, some kids did the problems, okay, and then they left their answer like this. I'm like, it's math class, people. What, you think you don't have to collect like terms? Come on, guys. Collect like terms. So now I got 10x minus 6 over x plus 2 times x minus 2. And then I told you you needed to look and see, can you factor this? Can you take anything out? A 2. And what are you left with?
5x minus 2.
So did it help me any? Can I reduce it? No. So then I said, well, then go back and circle that because that's my answer. All right? Now, can I check that? Can I make sure that that's my answer? Now, see, one of the kids already got mad at me because they were like, why didn't you show us that before we turned our worksheet in? And I said, because I'm trying to teach you to work with your friends. And he goes, what if my friends don't know how to do it? Like, you better find some new friends, okay? Come on, people. You need to learn how to work with other people. That's going to be one of your best skills when you go to college. Everybody in this room is going to take one class at least in college that's going to kick your tail. You better learn how to work with somebody. You better learn how to find somebody in that class of 300 people and say, I believe that person knows what they're doing. Hey, I'm so-and-so. Could we have a study group? I'll bring some pizza because I don't know what's going on. You see what I'm saying? You got to contribute something, people. You think college people won't come to a study group if you bring the pizza? Yeah, they're coming. They're eating cafeteria food.
Hey, cafeteria college.
No.
Lamar is good.
Is it?
Oh, it is.
Oh.
We went for
Yeah, they do. Some of them do. Some, and even if they don't have Chick-fil-A's in them, they have them on campus, and you can use your bare butts or whatever they call them now. Okay, so anybody know how I can check to see if this answer is right?
Plug in the calculator.
Oh, so now what do you mean, Abby? Plug it in the calculator.
Put it into y equals, and I don't really know. I don't know.
Okay, but she's on the right track. Let's see if we can figure it out.
You can change the number to like 2.
Okay, some of y'all are thinking this. Some of y'all are saying I could plug a number in and make sure that it got me the same thing right here that it gets me right here, right? Oh, so I could plug this one in Y1, and I could plug this one in Y2, and where should they be? On top of each other. Okay, so I'm going to show you how to do it. You don't have to do it, but I'm just going to show you something because I wanted to show you something on the calculator that's kind of cool that a lot of the kids didn't know about. Okay, so now, Luke, this is what I'm going to do. I'm going to go back, and these two equations, this is the left, or this is the one that I gave you, and this is our answer that we got. And actually, I may have changed the problem a tad bit, but anyway, it's the same thing, okay? So I'm going to show you how to turn them back on and off. You see? Yeah. I'm going to highlight. Oh, come on, little pencil. Hang with me. There he is. I'm going to highlight these equal signs, and then I'm going to go turn the other equal signs off. So he's not going to graph those. Okay? Now look what else I did. Notice on this one up here, who is that?
I don't know.
Go away. I don't know who those people are. So, all right. So on this one, I just got a regular line. But look at this guy. I went over here to the left. You can go over to the left on this. See, watch. And then you can press enter a bunch of times. Okay? Now this right here is just the ball. I have the tracer ball. I like the tracer ball better, but you could just do a ball. All right? But anyway, I'm going to go back and get the tracer ball. The ball doesn't leave a trace of where he's been. He just runs across the screen, but you can't tell where he was. The tracer ball runs across the screen, but he also leaves a graph behind him. So if he was a little bit off, I might could see it, and I might not see it on just the ball. Okay, so now watch what happens when I graph this. You know how when you graph two things on there, you can't tell if they're on top of each other? Because you're like going, whoa, wait, did it happen yet? Or is it off my screen and I just don't know it? All right, watch what this one does. Pretty cool. This is my first graph. Now here's my second one. Are they the same? Yes, they are. Okay? He's showing you, hey, this is the second one, guys. He's right on track. Okay? All right, so that's another way you can test and see if they are the same thing. Now listen, will it tell you that this answer is completely reduced? No. Because you can put this in there, and guess what it's going to do? He's going to say, hey, yes, I'm him. All right? But I'm not going to give you credit for it. Okay? So it will tell you, though, if you completely reduced it, if everything's okay. All right, anybody got a question? Okay, is everybody okay? You learned some stuff? Yes? All right, let's do one more problem, and then I'll let you work. Okay, this is example 6. It's on page 592. Okay? Now let me tell you the plan. The plan is tomorrow, I don't plan on seeing you guys, right? Okay, so you're testing or sitting in a room somewhere or whatever you're doing. Some of you aren't even coming, no, everybody's coming to school. Some of y'all are not coming to school, okay? So, but don't come to my room because I'm not in here, all right? Mr. Prejean's class is in my room, so you don't want to be in here, freshmen. They're up now, you just have to look for them, but they put them up. All right. So, I won't see you tomorrow. Friday when you come in, I like one thing teaching you. It's the extension on this chapter. It doesn't have another section, but it does have an extension. It's all on the calculator. Okay? So I'm going to teach it all to you tomorrow. If I don't get it all taught, then I'll cover it on Monday, and then any time left on Monday you can use to work on your worksheet or study for the test. Okay? So, that's my plan. We're testing on Tuesday and Wednesday, and I know some of y'all are out on Tuesday and Wednesday, so if you're out on Tuesday and Wednesday, Friday is messed up for you guys. Friday's going to be a free day for us because that's when y'all are making up the, TSI test.
Friday?
Okay, yeah, I thought it was Thursday, but they changed, they said now it's Friday. Not this Friday.
We're going to be doing district credit.
So, anyway.
April 8th, that's when sophomores make it up.
Yeah, sophomores are making it up next Friday.
You have to write an essay. Oh my god.
Hey, this second's fucking hard, dude. Yeah, right well.
But I can't do it.
Right back then.
And it's typing, so you don't have to like write.
Okay, so here we go, guys. So everybody knows the plan, right? Okay. So if you're going to be out Tuesday and Wednesday because you're a junior, then that's okay. I'll try and keep you covered. Maybe you can do it Thursday and Friday or something. You should only miss one of those days, so you should only have one day to make up. And Friday is a blow-off day, so you'll be in here on Friday. All right. So here we go. From 1995 to 2003. The annual sales S in billions of dollars of entertainment software can be modeled by this equation. S of T, the sales with respect to time, sales with respect to time. Now, what should I expect my sales to do with yeah, we're hoping they go up. People, if you got a business and your sales don't go up with time, you're not going to have a business very long, right? Okay, and so it's equal to, here's the equation, kind of a crazy one. 848t squared plus 3220 over 115t squared plus 1000. But they give you a little restriction. They say, hey, this equation's only good if t is between 0 and 8 inclusive. Okay? So, here's the question. And I'm rewording the question because I don't like the way they said it in the book, and I don't like the way they really answered it. Okay? So, I'm going to reword it, and I'm going to say, in which year do sales reach 5.3 billion? Oh, I'd be retiring. Okay? In which year do sales reach 5.3 billion? All right. So, what am I going to do, guys? Plug it in. What you going to plug it in for? T? What are you going to plug it in for? Oh, come on, you stupid thing. I hope they didn't think I was talking to y'all. Come on, you stupid thing.
Like X plus T.
What are you going to plug it in for?
T.
T? What's T stand for? Time. Is billions in time? No, not for any of us, people. You're going to plug it in for S of T. Very good. The sales with respect to time. Okay? So when my sales are 5.3 billion, how long or in what year will that happen? All right, so then it looks like this, right? Now, people, this is a rational equation. Should you know how to solve a rational equation? What do I do? Yeah, y'all, I'd slap that thing over 1, and then what would I do? I just cross multiply. So easy. Okay? 1 times all this stuff on top is all that stuff on top. 848t squared plus 3220 equals. Now I'm going to multiply 5.3 times all this stuff on the bottom. Okay? 5.3 times 115. 609.5 t squared. Very good. 5.3 times 1,000. 100. 5,300. Now what am I going to do? Yeah, get your t squared. I'm going to put my t squares on the left and my plain numbers on the right. So I'm going to subtract this 609, blah, blah, blah. So I'm going to subtract 609. Okay? What is 848 minus 609.5 t squared? 238.5 t squared. Can I do the other one at the same time? Is that okay? I'm going to subtract the 3220 from both sides. So what's 5,300 minus 3220? Okay, 2,080. Now what am I going to do? See, y'all know how to do this. Divide by 238.5. So t squared is equal to 8.72. Now what do? Square root it. Anytime you're solving an equation, that was a t squared, guys, sorry. Anytime you're solving an equation and you take a square root, you have to put plus or minus, thank you, 2.95. It is a real life problem.
No,
Ah.
wait. It can't be negative. It can't lose cash.
No, we're not talking about it. It's time. Now, y'all listen to me. Let me tell you something. If you say this, if you say it can't be negative 2.95 because that has to do with time, y'all listen to what you're telling me. You're telling me time didn't exist before 1995? I'm pretty sure it did. I was born before 1995. I know you might be shocked at that. Well, but it didn't say it started then. It just said, you know, it's talking about this time. Why is the negative 2.95 not good?
Because it's looking in which year between those years.
Oh, because 0, yeah.
Yeah, it says it has to be between 0 and 8. Is negative 2.95 between 0 and 8? He's outside my domain, people. Okay? So what's the only choice? 2.95. Took me in those 2.95 years. So here's what they asked. In which year?
1998.
In which year?
97.
Very good. In 1997. Which part of 1997?
December.
Oh, the very end. 2.95. Yes, we are almost to 1998, Abby. Okay?
I was thinking that it started at 19.
So everybody know where I got? Oh, it started writing again. 1995 plus the 2.95 is 1997.95. Y'all, that's almost 1998. But if I said in which year, I want you to tell me the very last part. December at the end of 1997. Everybody got it? Okay, so the problem that's on the board, there's a problem on the board right there. You need to write that on the back of your worksheet. It's due. It's a lovely problem like we did yesterday. Okay, so you should have practiced that one 3 times like I asked you to. Okay, and then that one, it's just like it. Let's see how good you are at it. Let's see if you can do it. So write that on the back of your worksheet, and then when's your worksheet due? I'm not even going to see you people tomorrow. So that answer is no. In what?
In May.
No, not in May.
June.
Oh my word. Y'all don't even listen to me.
It's due right
Thank
before the
you.
test.
Matt said due Tuesday. It's due Tuesday. When's your test?
Tuesday.
Who's not going to be here Tuesday and Wednesday? Juniors. Okay? Juniors won't be here Tuesday and Wednesday. But you'll only miss one day. So you only have to make up one day of the test, and Friday's a throwaway day. The sophomores won't be here, so we'll work on it then.
What are they going to do about me? Are you going to start recording?
You have to go.
I don't know what they're going to do about you.